A standard zero-turn deck belt hits 160 degrees during normal mowing. Within 50 hours at that temperature, the rubber compound hardens by more than 25%. That hardening creates micro cracks, and those cracks expand every single time the blades disengage and re-engage under load. Most homeowners never think about this until the belt snaps in the middle of the yard on the absolute hottest day of summer, with no warning, no spare, and no idea why. This video breaks down every belt category sold for a zero-turn mower, what the cheap one gets wrong, what the factory one actually solves, and what landscaping crews running 6 days a week put on their machines instead. There are 3 categories in this market. 2 of them will let you down eventually. One of them is the reason commercial crews stopped worrying about belts entirely years ago and never looked back. Every zero-turn deck belt fails the same way, and the process starts the moment the engine turns over. A rubber V-belt running at full load reaches roughly 160 degrees during normal operation. At that temperature, the rubber compound begins hardening almost immediately, and after about 50 hours, it has lost more than 25% of its original flexibility. Hardened rubber does not bend the way it was designed to. It cracks. Those cracks start microscopic, invisible from the seat of the mower, but they expand every single time the deck blades disengage and re-engage under load, which happens constantly during a normal mowing pattern around 3,000 to 3,600 revolutions per minute. Each engagement event sends a shock load through the belt instantly, and a belt that is already hardened cannot absorb that shock the way a fresh one can. The cord running through the center of the belt, usually polyester, stretches slightly under that repeated stress. A stretched belt loses full contact with the pulley grooves. Lost contact means slippage. Slippage generates friction. Friction generates heat. And that heat feeds directly back into the hardening process that started the entire cycle. It is a closed loop, and once it begins, it does not reverse itself. It only accelerates until the belt fails completely, usually somewhere between 50 and 150 hours of total runtime, depending on conditions, load, and how often the deck is engaged. For a homeowner mowing an acre or 2 once a week, that failure window translates to roughly 1 to 3 seasons before a belt snap. For a commercial crew running an 8-hour day, 5 days a week, that same window arrives in about a month. The belt that shipped on your machine was never built to last forever, and the one a landscaping crew installs after their first failure is rarely the same one they started with. There are 3 real categories of belt sold for this exact application. 2 of them will eventually put you back in this same cycle. Only one of them was engineered to break it. Walk into any big box hardware store or search a zero-turn deck belt online, and the first results that come up sit between $10 and $20. They are standard V-belts manufactured overseas, usually in China or Indonesia, sold under brand names that mean nothing to anyone who actually works on commercial equipment for a living. They cross-reference to the right dimensions. They fit the pulley. They install in minutes without a single problem, and then they fail faster than every other option on this list, by a margin that is not close. Nobody warns you about that at the checkout register either. The reason comes down to one material choice. These belts use polyester cord as the tensile reinforcement running through the rubber body, and polyester is genuinely fine for steady, predictable loads. Conveyor systems, fans, pumps, anything that runs in one direction at one consistent tension. A mower deck is the opposite of that environment. It engages and disengages under full engine load constantly, and every one of those engagements sends a shock straight into the cord. At operating temperature, with the rubber already hardening, that shock transfers directly into fibers that were never designed to absorb it. The cord stretches, the belt slips, the slipping generates heat, and the heat finishes the job the temperature already started. None of this shows up on the price tag, which is exactly the problem. A homeowner replacing a $12 belt once a year barely notices the cost. A commercial crew running the same belt sees it fail in roughly 4 to 6 weeks, and a crew that buys that same $12 belt 4 or 5 times in a single season is not saving money at all. They are spending $60 to $100 per machine in belts alone, before counting the technician's time to install each one or the lost hours the mower sits idle, waiting on a fix. The math against the cheap belt is not complicated. It just requires someone to actually run the numbers instead of glancing at the price on the shelf. Most zero-turn mowers ship with a belt that beats the generic import, and that belt is the OEM deck belt. Exmark, Grasshopper, and John Deere all manufacture their belts to the exact geometry of the machine they go on. The cross-sectional angle, the length, and the cord placement tuned to that machine's idler system. That is not a minor detail. Aftermarket companies design belts to generic dimensions because one product has to cover dozens of machines. An OEM belt is built for exactly one. Commercial Exmark operators report 600 to 700 hours on OEM deck belts before replacement, compared with 200 to 400 hours from aftermarket alternatives on the same machine. A Grasshopper operator documented reaching 650 hours on an original OEM belt before wear caused noticeable slippage. These are numbers from real operators, not manufacturer marketing. So the case against the OEM belt has nothing to do with quality. It comes down to price and availability. OEM deck belts for commercial zero turns typically run $55 to $90 at an authorized dealer, sometimes more depending on the model. Stocking spares for a fleet of 5 machines at that price means a real parts inventory investment before the season even starts. And OEM belts are frequently unavailable same day. Dealer stock varies, and documented cases exist of operators driving to a dealer mid-job only to find the part out of stock, leaving the mower sitting idle for days while the order slowly comes in. One operator described an emergency belt failure where the dealer ended up pulling a belt off a showroom machine just to get him back to work, which is an informal fix for a structural supply problem, not a real solution. The OEM belt is the right answer for a single machine or a brand with strong dealer inventory nearby. For a fleet running multiple machines on a tight schedule, the cost and the weight are real operational problems that have nothing to do with how well the belt actually performs. That distinction matters more than the price tag suggests. The belt commercial crews actually stockpile is built around Kevlar, a DuPont trademark for a class of synthetic fibers called aramid. The material was originally developed for ballistic protection, an exceptionally high tensile strength to weight ratio that does not degrade under heat and does not creep, meaning it does not stretch incrementally under sustained load the way polyester does. A Kevlar cord holds its length under shock loading. A polyester cord does not. That single difference explains every longevity advantage documented in the field. Aramid cord retains roughly 92% of its tensile strength after 1,000 hours of UV exposure, compared with about 45% for standard polyester cord. At normal deck operating temperature, the aramid cord does not feed into the hardening cycle that destroys ordinary belts, because the cord itself never stretches enough to generate the friction that starts it. 3 brands come up consistently when commercial operators order Kevlar mower belts: Gates, Stens, and Pix. Gates is the most recognized name in industrial power transmission, and its high power 2 line bonds the tensile cords directly to the belt body instead of leaving them loose inside the compound, spreading load evenly during a shock event. Gates belts sit on parts counter shelves at most auto parts chains, which means a same-day purchase instead of a multi-day dealer order, an advantage for anyone working a full schedule. Sten's True Blue is the second name that shows up in every forum thread on this topic, built around double-wrapped DuPont Kevlar cord inside a neoprene body that resists petroleum products, heat, and moisture. Operators with weaker dealer networks often specify it as a substitute. Pix rounds out the list, offering both standard and aramid construction in cog profiles that flex around small pulleys without generating internal heat. Priced around half to 2/3 of OEM cost, though it is harder to find on short notice. One operator on a tractor forum reported a Kevlar belt still running on a mower deck from the 1980s, an outlier, but one no standard belt could produce. There is one variable that decides whether any of this advice actually works, and it has nothing to do with material. Cross-sectional dimensions are not optional. A standard V-belt profile for outdoor power equipment is not automatically the same geometry as an industrial V-belt sold in the same nominal size. John Deere runs a slightly non-standard groove angle on several of its machine-specific applications, a detail confirmed in technical forum discussions by people with actual drive design experience. A Gates or Sten's belt cut to the correct profile and length will function exactly as expected. A generic industrial belt that looks like the right size from a hardware store shelf may not seat fully in the pulley groove, and that mismatch produces the same slippage, heat, and belt jump failures that get blamed on the aftermarket belt itself, when the real failure was dimensional, not material. That is also why OEM is still the right call for something like a mule drive on certain commercial decks. Not because the aftermarket material is worse, but because the proprietary cord alignment on that specific drive is tuned to tolerances a generic cross-reference does not consistently meet. On a standard deck belt in a standard profile, a correctly matched Gates High Power 2 Kevlar belt performs at or above OEM level for meaningfully less money. And once the dimensions are right, the decision collapses into simple math. A $12 generic belt that fails around 80 hours costs roughly 15 cents per hour in belt cost alone before downtime. A $65 OEM belt running 650 hours costs about 10 cents per hour. A $24 Gates Kevlar belt running 400 hours costs roughly 6 cents per hour. Every experienced operator who has ever tracked this number lands on the same answer independently without needing a sales pitch to get there. The cheapest belt on the shelf is never the cheapest belt over the life of the machine, and the only way to know that for certain is to run the math instead of trusting the price tag. 3 categories, 1 real answer. The generic belt is the one that always lets you down. The OEM belt is the one that works, but costs you in price and patience. The Kevlar belt, in the correct Gates, Sten's, or PIX profile, is the one that landscaping crews standardize on and never go back from. Not because it is cheap, but because over the life of the machine, it is the least expensive option. That is the reason every serious operator swears by it, and the reason your next belt should not be the one that came with the power.